Take an arbitrary angle theta. On a unit circle. An arbitrary angle theta on a unit circle. How do you get the sine and cosine of that angle? There you go. Make sure we label this so it's a unit circle. So that means x equals cosine theta and y equals sine theta. That's again by the way we've defined sine and cosine on a unit circle. And what's the radius of the circle?
1.
Just one, right? So looking at that triangle,
Okay.
what can we write?
Pythagorean theorem.
What's that? Well, let's think about the Pythagorean theorem.
X squared plus y squared equals 1.
Sure. X squared plus y squared equals 1. X squared is cosine squared. Y squared is sine squared. And so that's proving the first one, right? Cosine squared plus sine squared equals 1 is the exact same thing as sine squared plus cosine squared equals 1. So whichever order you put that in, it's the same thing. Okay?
Mm-hmm.
First one, proved. So how do we prove a second? What can we do to this equation to make it come up with a second? Anybody remember?
Oh.
Whichever one you want to do next, we can do.
Divide by cosine squared.
You want to divide everything by cosine squared theta? Bless you.
I got a paper.
What does that give us?
1 plus.
Okay, what's cosine squared theta over cosine squared theta?
1.
It's just 1. What is sine squared theta over cosine squared theta?
Tan squared theta.
That's tangent squared theta. And what's 1 over cosine squared theta?
Cosecant squared theta?
Secant squared theta.
Yeah.
By definition, tangent theta and secant theta. No, but I'm just explaining to you. If you left that off, I would understand that, okay? If you were doing this for somebody who had no clue what trig was all about.
Do you have to do all the, like, take an arbitrary angle and all that?
If I can see a logical progression, right, from where you started to where you went, and I can follow what you did. What I can't do is just accept, all right, you draw that circle and then say, oh, yep, that's why cosine squared plus sine squared equals 1. You gotta tell me more than that, okay? You gotta give me a little more than that, right? I gotta understand that you know that the x coordinate on the circle is the cosine of the angle. The y coordinate is the sine of the angle. You gotta be able to make clear, communicate that to them, okay? Otherwise, I would be giving you a problem worth 20 points that all you gotta do is draw that little circle and then start writing down identities and you're done. And that doesn't mean you know how to get from nothing to what we wanna show.
If I wrote all the blue stuff, that'd be okay.
If you wrote all the blue stuff like that in order, as long as it makes a logical progression, okay, you're in good shape.
I'm not gonna just,
I know, I'm just trying to explain, because, so believe it or not, somebody out there would say, hey, all I gotta do is draw a circle, and then write my identities, boom, I'm done. Okay? Not saying you would do that, but somebody would. It's gotta make sense. And there's a reason that I'm going into this much detail, and that's because after this test, almost everything we do is proofs. Almost everything we do.
we don't have one test left, right, after this.
Yeah, except for the final. Yes.
Yeah.
Okay, this is the second one, okay? So how do we prove the third one?
Divide by sine squared theta.
Okay, we'll go back up to the original identity. And divide by sine squared theta instead. What does that give you? What's sine squared over sine squared?
1
Equals
cosecant squared
cosecant
theta.
squared theta. That's by the definition of cotangent. And cosecant. And therefore, sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. And 1 plus cotangent squared theta equals cosecant